Chefs and bakers use thousands of eggs daily. These eggs are usually purchased from the wholesaler in dozens, a dozen being a package of 12 eggs. So instead of counting out 120 individual eggs, the baker would simply count out 10 one-dozen units or cartons of eggs. In like manner, chemists report numbers of atoms, ions, and molecules using a unit called a mole. Just as a pair of any item means 2 of those items, a dozen of any object means 12 of those objects. So a mole of any object means 6.0221 times 10 to the 23 objects, if you are able to count them. Now you may ask, why such a huge number? To illustrate why a mole is comprised of such a huge number, we could give someone 12 grams of carbon-12 and ask them to count the number of atoms. Individual atoms are, however, too tiny to be seen, hence counting them directly would be impractical. The number of atoms in 1 mole of carbon-12 can be determined indirectly, however, if we know the mass of 1 atom of carbon. Using a technique called mass spectrometry, the carbon is ionized or charged and passed through an electromagnetic field where the abundance of the ion in a sample is calculated. The mass of a carbon-12 atom has been found to be equal to 1.99265 times 10 to the negative 23 grams. Therefore, the number of atoms in exactly 12 grams of carbon-12 is 12 grams divided by 1.99265 times 10 to the negative 23, which is equal to 6.0221 times 10 to the 23. This is called Avogadro's number. This heap of 12 grams of carbon therefore contains Avogadro's number of carbon atoms. Therefore, the mole is the amount of any substance which contains as many particles, be they atoms, molecules, or ions, as there are atoms in 12.000 grams of carbon-12. 1 mole is the amount of substance that contains Avogadro's number of particles of that substance. When speaking of the mole, we must specify the elementary entities that we are referring to. That is, atoms, molecules, ions, electrons, other particles or specified groups of such particles. For example, oxygen occurs in nature as a gas, O2, which is a molecule containing 2 oxygen atoms. 1 mole of oxygen atoms equals Avogadro's number of oxygen atoms. 1 mole of O2 molecules equals 2 times Avogadro's number of oxygen atoms. Note that 1 mole of O2 molecule equals 2 moles of oxygen atoms. Examples: how many atoms of hydrogen are present in 1 mole of H2 gas? 1 mole of H2 equals 2 moles of hydrogen atoms. 1 mole of hydrogen atom equals Avogadro's number of hydrogen atoms. Therefore, 2 moles of hydrogen atoms equals 2 times Avogadro's number of hydrogen atoms. So, 1 mole H2 is equal to 2 times Avogadro's number of hydrogen atoms. How many molecules of HCl are present in 0.4 mole of HCl? 1 mole hydrochloric acid equals Avogadro's number of molecules. 0.4 mole equals 0.4 times Avogadro's number of molecules. The masses of all atoms are compared to a standard. Originally, hydrogen was taken as the standard unit and given a value of 1 atomic mass unit corresponding to the single proton in its nucleus. Compared to hydrogen, therefore, oxygen would have an atomic mass of 16, equal to the number of protons and neutrons in its nucleus. A carbon-12 atom has 6 protons and 6 neutrons. Therefore, its AMU is equal to 12. A magnesium 12 atom has 12 protons and 12 neutrons. Therefore, its AMU is equal to 24. Nowadays, hydrogen is not taken as a standard, as it has been found to be contaminated with large amounts of deuterium. Instead, 1/12 of the mass of a carbon 12 atom, which has the same mass as a hydrogen atom, is used. This means the AMUs are the same. So oxygen has 16 times the mass of 1/12 of the mass of a carbon 12 atom, and magnesium 24 times, etc. The relative atomic mass, or RAM, of an element is the number of times an atom of that element is heavier than 1/12 of the mass of a carbon 12 atom. Using 1/12 of the mass of a carbon 12 atom as a standard, we can also compare the mass of molecules. The relative molecular mass, RMM, is the number of times an average molecule of a substance is heavier than 1/12 of the mass of a carbon 12 atom. The RMM of a substance is calculated as the total of the RAM of all the atoms of the various elements that make up the molecule. The more general term of relative formula mass is used so as not to limit the concept to molecular compounds only. Relative formula mass is defined as the number of times the mass of a compound represented by its formula unit is heavier than 1/12 the mass of a carbon 12 atom. The following steps may be observed when determining the relative molecular mass or relative formula mass of a compound. 1. Identify the atoms or ions present. 2. Multiply the relative atomic mass of each atom or ion by the number of such atoms or ions present in the formula unit or molecule of the compound. Add the products obtained. Based on the definition of a mole, the mass of 1 mole of the atoms of any element is equal to its relative atomic mass. For example, a mole of carbon 12 atoms is 12 grams. A mole of hydrogen atoms is 1 gram. A mole of hydrogen molecules is 2 grams, etc. Given the relationship between RAM and RMM or RFM, it follows that 1 mole of a substance has the mass that is the same as the RFM or RMM expressed in grams and is simply referred to as the molar mass of that particular substance and is usually expressed in grams per mole. The RAM of gold is 197. This ring weighs 197 grams. Therefore, it contains 6.02 times 10 to the 23 gold atoms, or 1 mole of gold atoms. Note well, the molar mass of a diatomic substance is equal to twice its atomic mass. Oxygen is diatomic, hence its RMM equals 16 times 2, which is equal to 32 AMU. The molar mass of oxygen gas is 32 grams per mole. The RAM of every element is accurately recorded in the periodic table. Using these values, the RMM or RFM of a substance can be calculated. Once the RMM or RFM is known, the molar mass of the substance can be deduced. This is done by simple proportion, where given mass is divided by molar mass to give equivalent moles, and given moles is multiplied by molar mass to give equivalent mass. For example, how many moles are present in 10.6 grams of sodium carbonate? Relative atomic masses. Sodium equals 23. Carbon equals 12. Oxygen equals 16. The RFM of sodium carbonate is equal to 23 times 2 plus 12 plus 16 times 3 is equal to 106 AMU. Therefore, 1 mole of sodium carbonate has a mass of 106 grams. The number of moles equals given mass G divided by mass of 1 mole, gram per mole, is equal to 10.6 grams divided by 106 grams per mole. Example 2. What is the mass of 0.2 moles of calcium carbonate? Relative atomic masses. Carbon equals 12. Oxygen equals 16. Calcium equals 40. First, we calculate the RFM of calcium carbonate. Is equal to 40 plus 12 plus 3 times 16 is equal to 100. Mass G is equal to the number of moles times the mass of 1 mole or molar mass, which is equal to 0.2 mole times 100 grams per mole equals 20 grams. Therefore, 0.2 mole of calcium carbonate has a mass of 20 grams. The number of individual entities or particles, atoms, molecules, or ions can also be calculated from the RAM and RFM. Earlier, we said that 1 mole of a substance is the amount of that substance that contains the same number of atoms as the carbon-12 atom. This is Avogadro's number, 6.02 times 10 to the 23 atoms. It follows that 1 mole of any substance contains this number of particles, be it atoms, molecules, or ions. In simple terms, if the number of particles or individual entities is known, then the number of moles of the same substances can be found, and vice versa. For example, how many atoms are present in 56 grams of aluminum metal? For a question like this, the first thing to do is to state that which we already know. The molar mass of aluminum is 27 grams per mole. 27 grams of aluminum metal contains 6.02 times 10 to the 23 aluminum atoms. Therefore, 56 grams of aluminum metal contain 56 grams times 6.02 times 10 to the 23 atoms, which is equal to 1.24 times 10 to the 24 atoms. Example 2. How many moles of aluminum are comprised of 1.24 times 10 to the 24 atoms? Again, we put in the information we know. 6.02 times 10 to the 23 atoms are contained in 1 mole of aluminum. Therefore, 1.24 times 10 to the 24 atoms of aluminum contains 2.06 moles. The same principle applies if we were to calculate the number of molecules in a given mass of a gas or the number of moles contained in the given number of molecules of the gas. That concludes the first part of our lesson on mole concept. Join us again for part 2.